Good morning. Today we are doing our last objective of Unit 4, CO28. Wrapping up all of this percentages that we're talking about, we are now going to calculate simple and compound interest. Oof, getting into the adulting world. Okay. My kids, 2 of them are in college, and they're getting some loans to help pay for college, and we've had to look at that interest rate. This is a real thing. They're not that much older than you. Okay? So this is something that you're really going to want to look at. Getting credit cards, you have to pay back interest rates on it. On loans, you pay back interest rates. Putting money in the bank, you can make interest on your money that you're saving. You can be doing that right now. So this pertains to you. It is important to you. At this moment, you might go, I really don't care about simple and compound interest. You should start caring, okay? This is your finances going forward. This is something you need to be aware of as you get older. So this is an important objective in the real world. So having financial intelligence can help you make informed decisions that can end up saving you a lot of money in the long run. When you borrow a large amount of money from a bank or make a large purchase on a credit card, you are charged the interest rate because, for example, $20,000 today won't have the same value by the time you eventually pay it off due to inflation. So we talked about that beaver hats in social studies and how much they costed then and how much it would cost in today's world. And it would be like $300 now. It wasn't $300 200 years ago, right? Their money, it was worth less than it is now. So if you weren't charged interest by the company you are borrowing from would lose money. So if they're giving you money and you get it paid off in 20 years, well, in 20 years, they're not getting interest on it, they're actually losing money. And they don't want to lose money. Even on small loans or purchases, charging interest is a way for companies to make money in general. So a lot of times you'll see they charge a higher interest rate so they can make more money off of us. So you want to be careful. As you get older and you look at opening a credit card, you want to make sure you're paying attention to the interest rate. Don't go for the one that your friend has, go for the one that's going to save you the most money. Okay. So interest isn't all bad. Money that is deposited into certain types of saving accounts can earn interest for you. So as you're putting money into the bank, if it's a savings account, make sure you're getting interest from it. You're getting money for the money that you're saving, and you can make more. There are 2 different types of interest we're going to learn about: simple and compound. So the first thing we're going to do is talk about the different parts of the formulas we're going to be working with. So the first thing is the principal. The principal is the original amount. So it could be a loan that you take out, it could be a deposit that you put into the bank, something like that. So it's the original amount. Today, I am borrowing this much money to buy a car. So this is my original amount. That's the principal. The rate is the interest rate. So the percent you're going to be charged. If we're going to be charged something on a loan, do we want it to be a high interest rate or a small interest rate? Small, right? So when Mateo and Rosa this summer were looking at taking out loans for college, we shopped around. We went, okay, if we go through this loan company, charging an 8% interest rate, that's ridiculous. That's going to be so much money you have to pay back. So we found one, we had to take time and do work, but we found ones for 4% interest rate. Big difference. Saving them money in the long run. The time is how often the interest is applied. Is it applied every month? Is it applied every year? So it's that time. So simple interest, now that we know the principal, the rate, and the time, simple interest is interest charged on the principal only. Now there is a formula for this. So we have our original amount, I'm borrowing $5,000. I want to find out how much I'm gonna be using this. I have this loan for 8 years. How much interest am I going to pay on that $5,000? So I'm gonna take the principal, I'm gonna multiply that by 1 plus rate times time. So remember, we do inside the parentheses first, Form does. Which part of inside the parentheses do I do first? What's the very first calculation I would have to do? Yeah, the rate times the time. Then I add the 1, because it's inside parentheses. Then I multiply it by the principal. So here's an example. If I have $100, if I have $100 loan at 10%, simple interest annually. I'm going to see how much I owe over time. So I'm going to make a little chart here. I have my year. Okay. 1, 2, 3, 4, 5. All right. So this is my balance. So the year is on top, the balance is on the bottom. So at 0 years, when I first take out my loan, how much do I owe? If I take out $100, how much do I owe? $100, right? Because that's how much I just took out. I haven't accrued any interest yet. So in the beginning, I owe that $100. After a year, I'm going to have interest applied to that. So now I need to do the math. So I have my $100 principal. I have 1 plus the rate, which was 10%, 0.1, times the year, times 1 year. So what is 10% times 1? Say it louder, Hadley. What is 10% times 1 would be 10, what number? So I don't want to go to percents anymore. 10, right? Is that right? Am I doing this right? Let me just, I'm all thrown by all the screaming that was happening. Trying to get myself back on track. This is why we should not be obnoxious when people are doing hard math, right? This is a new concept for us. We want to make sure we are doing it correctly. So 0.1 times 1 is not 10. I didn't think that sounded right. 10% times 1 for 1 year would be what? It's not 10. Robbie? 0.1. And I want to do 1 plus 0.1, which would be 1.1. I'm multiplying that by my 100. Okay, so we shouldn't guess our numbers. Use your calculator to make sure you're doing the math right. Multiply it, add it to 1. So 10% times 1 was 0.1. Added to 1 is 1.1. Multiply that by 100, and what do we get, Harper? 110. So after 1 year, instead of owing $100, I'm going to go owe $110. What am I going to owe after 2 years? So now instead of a 1 here, we're putting a 2. So that 0.1 times 2 gets us 0.2 plus 1 makes it 1.2 times 100. What do I get? Michael? 120. So in 2 years, I owe $120 now. So instead of just owing $100, now I owe $120. How much interest was that put onto my original $100, Luke? Tell me the amount. How much interest was put onto that $100 if I now owe $120? Graham? Yeah, so it's $100 your original principal, and now you also owe $20 in interest. But I have this loan for 5 years. How much am I going to owe after 3 years, after 4 years, after 5 years? Who's done the math? How much are we gonna owe, Robbie?
130, 140.
Yeah. So the example that he gave us, if we did all of that math, we can see it's just increasing by $10 each time because he gave us easy numbers to work with. Are we always going to have easy numbers to work with? No. Okay. But do we understand the concept of how to do the formula? We use easy numbers when we're learning the formula. To get to that final $150, I did my principal of 100. Then I have my parentheses, 1 plus my rate, 10% is 0.1, times my 5 years. So first I multiply 0.1 times 5. What is that, Rocco? Use your calculator. 0.1 times 5. .5. What do I have to do next? I have to add that 1 to it. Because I always do inside my parentheses first. So I have 1.5. 1 plus 0.5 is 1.5. And I'm multiplying that now by my principal. So what is 1.5 times 100? See how we got that now? Is it making sense? Because you were looking confused before. Is it starting to make a little sense? The more we use a formula, the more it makes sense, the easier it comes. So, erase this. So our simple interest formula, we're going to write it again. It's that important to know. Simple interest formula. Let me scroll up a little more. Principal times 1 plus the rate times the time. That's the formula we need. You will want this on your help sheet. You will want to label it simple interest because we're also going to learn compound interest. 2 different formulas. So when you put it on your help sheet, make sure you label which one is simple and which one is compound. So simple is a bit easier. It's going to be a lot less because we're only putting it on the principal. Look at what compound interest does. Compound interest is interest applied to a running total on the loan. So both principal and interest. So with the simple interest, we were just finding after 4 years on that $100, we would do the, with the compound, that principal number keeps getting added to the previous interest. And you're getting charged not just $100, but if you made, after a year, it was 110, so after 2 years, we wouldn't be going with the 100, we'd be going with the 110, right? There's a formula, though, that we use to figure this out, because we don't want to have to figure out all the years in between. We want to see at the end of the loan, how much interest are we going to be paying? So, before we do the example, let's write what this formula is. We have our principal times 1 plus the rate to the time power. So we're going to be using that exponents. So let's see what that means, how we work this out. So we have that $100 that we took out. We want to see how much we're going to pay over 5 years. So we're going to work it out 1 year at a time. So we've got our year, zero, 1, 2, 3, 4, 5. We have our balance. We take out our $100 after year 1. If we use this, we would say, well, our principal is 100 times 1 plus the rate of 0.1 to the first power, right? Because it's been 1 year. So we would do 1 plus, our rate is 0.1, so that's 1.1. Remember, our exponent button is that little arrow. I've showed you that, right? Yes or no? Yes, okay. So to the first power, it's still going to be 1.1. Then we multiply that by the 100, by that principal, and oh, we get the same as what it was for our simple interest. After 1 year, it's going to be the same, $110. Watch how it changes for 2 years. Who remembers what it was for 2 years for simple interest? What was it, Hadley? Yeah, it was 120. I'm just going to write that little there because I don't have it on my screen. Look at what happens. We're going to do that principal of 100 times 1 plus that 0.1, but this time we're going to do it for 2 years would be the second power. So 1 plus 0.1 is 1.1. Now I have to square it next because exponents come next in perm dust. So that's to the second power is 1.21. Now I multiply it by that principal of 100, and oh, it's not $120, it's $121. So let's look and see what happens with our third year. Third year in the simple was 130. Third year with the compound, I have 100 in parentheses 1 plus 0.1. This time my time is 3 because it's 3 years. So I'm going to do that adding on the inside. 1 plus 0.1 is 1.1. To the third power is 1.331 times that principal of 100, and I get 133.1. So that's $133.10. So over time, which one is going to cost us more? Michael? The compound. The longer it goes, the more interest is accrued that you are getting your compound interest on. That gets added to that principal, and it becomes bigger. So which kind of loan would you want to take out, a simple loan or a compound loan? Simple, because that number keeps going up and up. So for the simple it was 140, if we do all of our math, this becomes $146.41. And for 5 years, simple was 150. For the compound, if we do that math, it's $161.05. The longer it goes, the bigger the interest that's being put on it becomes. Because then that running total is bigger that we're using. Does that make sense? So the compound interest, whew, it gets big. Do we understand the difference between simple and compound with those formulas? Okay, so we have in our problems, it will always say if it's simple interest or compound interest. So we have to pay attention to that in the problem. We have to know which formula we're going to use. So let's see what that looks like. Let me erase and scroll up so we can work some out together. So on our second page, what do you think you're going to want to put at the top of your page? You're going to want to put those formulas on there so you don't have to keep turning back and forth. So I'm going to put the simple over here. So that was the principal, 1 plus rate times time. And I'm going to put the compound over here just because this is what I have room for. Principal 1 plus the rate to the time as the exponent. So if we look at our first problem, it says, your bank gives you a $1,000 loan to buy a jet ski and charges you, I'm going to underline it because it's that important, simple interest. So I'm underlining that so I know which formula to use. And then it says 12% for 3 years. How much interest is earned on the loan and what is the total amount you will owe the bank. So I'm going to go back and I say, okay, I need to know my principal, my rate, and my time. So what is my principal? Claire? The $1,000. So I'm going to put a P above it because I need to know what I'm filling into my formula. What is my rate? Christina? 12%. So be careful, it's not 12. You have to remember it's 12%. So when we multiply it, we're multiplying by 0.12, not 12, 0.12. What is my time? Harper? The 3 years. So now I know what to put into my formula. It's simple interest, so I know I'm using this one. My P is my principal. I know that's $1,000. Then I have my parentheses. I have my 1 plus my rate, which is 12%, 0.12. And I'm going to multiply that by my time. My time is 3 years. So what's my first step I'm going to do? David?
Multiply 12.12 by 3.
PERMDAS. I need to multiply 0.12 times 3. What do I get? Hadley? 0.36. And I need to add that to 1. Because that is inside the parentheses. So 1.36. What is my next step? Harper?
Multiply 1.36 times 1,000.
Yeah. So I multiply that by 1,000, and what do I get? LJ?
136.
Nope. 1 plus 1.36 is 1.36. I times that by my 1,000. So 1,000 times 1.36. Did you use your calculator? Do it again. 1,000 times 1.36. What'd you get? $1,360. So now we need to figure out, is that how much interest is earned on the loan, or is that the total amount we owe the bank? So our principal was 1,000. We do our formula. After 3 years, we see that 1,360. Do you think that answers the first question or the second question? What do you think? Fallon?
The second one?
Yeah, that's the total amount we're gonna owe the bank. So this is our total. So how can we figure out how much interest accrued? Claire?
1,306 minus 6,000.
We're gonna take the principal off of it. So we know we took out $1,000. Now after 3 years, we owe 1,360. So we subtract that principal from that total amount, and the interest that we owe is going to be $360. Okay, so when we do the formula, it's telling us the final amount after that range of time. To find out how much interest that is, you subtract off the principal amount. Does that make sense? Let's look at our second, oh no, the second one is another simple. I want to go down to a compound one. So, always make sure you're answering all the questions being asked. This one asked 2 questions. On the test, if you're asked 2 questions, you must give 2 answers. So make sure you label which answer is which. This is the total amount, this is the interest amount. Labeling it so I know. And you're completely answering your question. Let's try one of these compound ones. So you take out a loan with interest compounded annually at 1%. The amount of the loan is $5,000 and you plan to pay it off in 6 years. How much interest is earned on the loan? What is the total amount you owe the loan company? So I'm going to underline compounded so I know which formula I'm using. What is my principal amount? What do I put in for the P? Hadley? $5,000. What is my rate? Amala? 1%. And what is my time, David?
6 years.
6 years. So now I know which formula to use. I'm using the compound. I know all of the things the variables I need to put in. So my principal is $5,000. 1 plus my rate, 0.01, to the 6th power. That is my time. So the first thing I do is what? Hadley, or no, I just called on it. Vivi. We do what's in the parentheses. 1 plus 0.01 becomes 1.01. What's my next step, David?
After you have the 1.01, you square it by 6, or you multiply it by 6.
I do not multiply by 6.
You go to the 6th.
I go to the 6th power. Very different.
That's what I was trying to get at.
Yep, you go to the 6th power. So 1.01, you do the little arrow to the 6th power. What do I get? Harper?
1.061, or
Yep, rounding to that 100th place, I get
yeah.
1.061. 1.06. What's my next step? Now I'll go with Hadley. I multiply it by that principal. So 5,000 times 1.06. And what do I get? Luke? 5,000. It's not just 5,300. You know what it is, Luke? Oh, wait. I was looking at the wrong thing on my paper, I think. Wait. Oh, so here's what we're gonna change up. We don't round until the very end. Okay, so we're not gonna do 1.06 and stop there. We're gonna keep all of those decimals on there. Okay, we're not rounding till the end. So you don't have to write this number all the way down. You can, okay. We need to know it's 1.01 to the 6th power. We multiply that by 5,000. So who can redo that without rounding until the very end? Luke, what do we get now?
5,307.60.
Yep. Okay. So it does change our answer. So we want to make sure that we round at the very end. Okay? Because we don't want to shortchange the bank their $7. They want their $7. Okay, trust me, the banks want every cent they can get. So we will round at the very end of our formula. So our questions are, how much interest is earned on the loan? What is the total amount you will own? You will owe the loan company, not own the loan company. Owe. How much are we going to owe? Who can tell me which answer we have right there? Fallon.
The total?
This is our total, so you want to label it. The other thing I need to answer is my interest. Who can tell me how much interest we owe? Camilla? Yeah. We subtract off that principal of 5,000, and we know that we owe the bank $307.60. Does that make sense? Okay, we have a few more problems that we need to do on this page. If you finish, remember, you should be starting to work on that help sheet for tomorrow. If you do not finish, make sure it's homework. You finish it tonight, we will answer it tomorrow, and then we will have the practice test. So you will want to work on that help sheet tonight. We have formulas, and friends, I don't remember these formulas off the top of my head. You will want to put it on your help sheet. You want to label which objective it goes with, which one is the simple, which one is the compound. Make sure your help sheet will be useful for you. Every single person should have a help sheet tomorrow. I do not want people saying, oh, I'll remember the formulas. When it comes to formulas, you need to put them on your help sheet. Okay. Any questions? All right, if you are watching this at home, I hope you are well, and I hope to see you soon. Make sure you ask me if you have any questions. Practice test tomorrow. Have a wonderful day.